Welcome to Full Steam Ahead. My name is Lori, and today we're making a Newton's Cradle. So this is a Newton's Cradle. It's also called a pendulum. It's named after Isaac Newton because it follows a couple of his laws of energy and motion. So what his law states is that when two things collide, the momentum created by one object will be transferred to the other object, and the momentum will equal what was created by the first. So this is creating momentum, it's being transferred, and then equal momentum by the second one. So how that works in a pendulum is that you have 5 spheres, and they're usually metal, and that's actually very, very important in this project. So, but we'll talk about that in a minute. So you have the first one creating momentum, and when it impacts, it transfers that energy through to the last one. That one goes up. So momentum and transferred and momentum. So let's talk a little bit about the frame. So I started off making the frame, and I made a simple cube, but there was a lot of movement. It rocked a little bit, and for an experiment about motion and energy being transferred, I had to stop any motion coming from the frame itself. So I reinforced it by putting sticks in the corners, and then I also put sticks on the sides so that it creates a triangle. Now, let's talk a little bit about the spheres. So I used 8-inch pieces of string, and I glued them to the top of the marble, and then I glued them onto the sticks. Now, this took a little while because I had to make sure that they were lined up in a precise line. Any deviance, if they were just off just a little bit, that would impact how they impact each other and transfer that energy. So you have to be kind of precise about how you glue them onto the sticks. Now, another thing I wanted to see is about the different masses in the balls, because one of the laws states that one scientific law states that momentum is directly related to the mass of the balls. So if I have different spheres, the higher the density, the stronger the force of momentum. So if they're denser, they're going to move more. So I got wood, and wood isn't very dense. So I wanted to see how that would work in a pendulum. And then I have the glass beads as well. So the marbles they're going to have more mass than the wood, but the most common material to use for this is metal. That's because when hard metal collides, it doesn't deform, and when it hits, less energy is lost. So with wood, it has less mass, and it also has elasticity and kind of bends when it hits. So it's going to have less energy moving through it. So let's see how the glass works. So you're going to create momentum. So you have a little bit of movement. Let's see about the wood and see how that works. So we're going to create momentum. So not very much movement at all. So we have the initial impact. We'll use the glass again. So with the initial impact, it's going to be stronger because when it hits, all that energy is going through. Now it slows down for a couple reasons. When it hits, there's friction when they hit. And also, the material itself, there's elasticity, and it's going to deform a little bit, so lose some energy. And also, because energy cannot be destroyed, it has to go somewhere. So that energy is changed from that initial momentum. It's changed into kinetic energy. And then, so some energy, you have the initial impact, some of the energy is lost, and then when it comes down on the other side, it's not as strong. So you're going to have less movement after that first impact. So yeah, that is Newton's cradle. So if you do it, so there are a couple things that you could try. Because spheres because they're round, they have one point of contact. All the energy is being focused on one point. If you use a cube, it has a larger point of impact. So all the energy being transferred is through a larger surface. So that is going to impact how the objects transfer energy. So if you do this, you could try using different sizes. You could try different shapes to see if that impacts how the energy is transferred. You can try using different materials, like I did. You could use more spheres and see if that has any impact, or even the length of the string, see if that changes anything. So there's a lot of possibilities with this project, and I'd be very interested to see if any of you have done it and if you change anything and had different results. So if you would like to let us know how you did, how your project ended up, you could email us at the library at info@airdriepubliclibrary.com. And thanks for joining me, and I hope you enjoyed this experiment.